What's poppin', dogs? Mr. Allen here, working with some polar and rectangular equations and switching between the two, or converting between the two. So for this first one, I have write the equation in polar form. It's given in rectangular form. That should look kind of familiar. It's the equation of a circle with the center of, little review here, 9, 0, and a radius of square root of 81, which is 9, right? Fun fact, right? Not part of this problem here, but just a little rehash in case you see that maybe on the SAT or ACT. I got you, bro. All right. To convert it into polar form, I'm going to need to expand this part right here. X minus 9 times x minus 9 is how you have to think of that, right? So that becomes x squared minus 9x minus 9x, which is minus 18x. Negative 9 times negative 9 is positive 81. And our y squared doesn't change, nor does the 81 over here. Now I can do a little simplifying, right? I can subtract 81 on both sides, and boom, those guys are gone. Wonderful. And now I have x squared. I'm going to put the y squared with it. That's advantageous to convert into polar form here. Minus 18x equals 0. All right, now we're ready to rock and roll. We're ready to get going into polar form now that we've got it all cleaned up. X squared minus y squared, that equals r squared. All right, so I got r squared is replacing those two right there, and then minus 18x. Well, let's see here. On my unit circle, right, let's make some connections here. On my unit circle, x is cosine and y is sine. And the same goes here in polar and all that stuff. We have a lot of connections here. So x is going to become r times cosine of theta. So we're going to have minus 18 r cosine theta, and that all equals 0. So the x right here, my little teacher brackets, it's tiny, it was replaced by this bit right here. Okay, so that x became the r cosine theta. Cool. So we are in polar form, but we're going to clean it up a little bit more. I can take out an r here, making it r minus 18 cosine theta. And I know we usually try to avoid like getting rid of a variable, especially when like solving with trig and stuff like that. So this might seem weird, but we are going to divide by r here. Because r equaling 0, that would mean by a radius is 0, and that's not going to happen, right? So we'll have r, at least not going to happen for graphing these. So we're going to have r minus 18 cosine theta equals 0, and you could really just have then r equals 18 cosine theta. How beautiful does that look? That's if we think about our graphs here, actually, if you were graphing this, this is the equation of a circle, right? Which is what we already said. And if I were to graph it, it would look something like this. I know this is on my shirt right now. It's probably a little hard to see. But cosine, I'd start at the 0 here, and I'd go all the way to 18 over here. And I'd have this circle with a diameter of 18 and a radius of 9. Look at that. Look at that. We just connected the dots. We went really, if you will, full circle in this problem here, connecting it back to the original. That equation looks way better than that one, though. So you can kind of see, like, sometimes the advantages of having different forms in math, like polar. Wow, that is a really clean equation as opposed to that mess right there. Wait until we get going on this bad boy. Okay, so we got ourselves a circle. Now, over here I have r equals 5 minus 4 sine theta. So what can I do with that? Well, what if I were to, I got sine theta, and didn't I say r cosine theta is equal to x, so r sine theta is equal to y. So if I had an r here, then I could be in business, right? So let's do this. Let's multiply both sides by r, okay? Kind of like how we divided by r on both of these. We're going to go the other direction here since we're converting now to rectangular form. So this gives me an r squared equals, I'd have 5r minus 4r sine theta. Now over here, I know I could have x squared plus y squared, right? Then I'd have 5. Let's actually save that guy for a sec here. Let's think about this one. This would be minus 4y, right? So minus 4 and then y, because r sine theta is equal to y, r cosine theta is equal to x, okay? Back to this guy here. If r squared equals x squared plus y squared, then r would equal the square root of x squared plus y squared. So I can have 5 square root. I had a college professor that whenever he said square root, he sounded like Count Dracula. He's like, square root of. Anywho, a little flashback there for me. X squared plus y squared. That minus is not in the square root there. It's going to bother me. But this is basically it, okay, guys? Like, it looks terrible, right? You don't really have to do anything further from here. We can just leave it as is. I'm going to write it again just because I don't like the, how how the square root worked itself out there. I didn't really leave myself enough room. X squared plus y squared, and then minus, whoop, boop, minus 4y. That right there is my rectangular form of this one. And as you can see, this looks like a limousin, right? Because they're two different numbers here. Whereas if they were both the same, it's going to be a cardioid. Two different numbers, a limousin. This is the graph of a limousin in rectangular form. How wonderful. So I don't really want a graph with that, right? I'd rather do that one there. So polar again for the win in certain types of graphs, and you can see the importance there. But that's how you go back and forth between the two. You may be asked to do that, and hopefully that helps. See you guys later.